Hello guys, so am I audible? Please respond in the chat box. Okay, cool. Yeah, okay. So welcome back to new short session. Okay, the session won't be too long today, okay, because I have to go somewhere. So yeah, alright, so I'll give you basically a few things about data link layer. Today we are going to discuss about flow control, error control, access control, all these things one by one. If you remember, since I haven't received any doubt, so I'll consider that there is no doubt till now at the moment. Alright, so if you remember yesterday's class that I had told you that there are different functionalities of your data link layer. Okay, there are different functionalities of data link layer. The first one was it ensures this thing, that is node to node delivery, the very first thing, right? Then second one, it does one more thing that is known as framing. Basically it creates data frames out of data packets, right? Then it ensures flow control, or it provides flow control. Then there is error control. Then we have access control, and obviously there is one type of address that is used, so it also does something that is known as physical addressing. Alright, so this is what we have till now. Alright, so we already know about what is node to node delivery, we already know about framing, we already know about physical addressing. We are yet to know about these three things, right? So we'll basically start with flow control. That's why the very first topic is flow control. Okay, so flow control is a basically it is a mechanism. Okay, it is a mechanism. Now how can I give you an example of, or how can I make these things interesting or easier for you guys to understand? Okay, so let's say there's me. Okay, then there are you guys. Okay, a group of people who are studying from me. Alright, so basically I am trying to share information to you guys. Alright, so what happens over here is that there is one sender and whatever the number of receivers are there. Okay, so this one is sender, on the right hand side they are receivers. Okay, now if since I am teaching you at the moment, if I start speaking very quickly, okay, if I'll explain everything in a quick manner and my communication speed is very fast than usual, it might be difficult for some of you guys to interpret everything in a correct order, right? Obviously you will be able to capture the things, but what I mean to say is if I'm too fast, it would be very difficult for you to pick up my words, right, or pick up my sentences, to pick up the sense that I'm talking about. Alright, so it would be difficult, right? So we can say that my speed of communication is dependent on the level of interpretation that you guys can make. Okay, and if you can understand, if all of you guys are fine with faster communication speed, then I'll be speaking at a faster rate, right? But let's say if you are able to understand only 60 words per minute, so I'll be speaking in this order only. Okay, so can I say something that the primary focus over here is someone that is known as receiver. Okay, if just analyze this scenario, if there is a sender and there is a receiver, they are trying to communicate with each other. If the speed of sender is, let's say, 100 words per minute, speed of sending the data, but at receiver's end, okay, the speed of processing the data is only 60 words per minute. Now where does efficiency stand? Okay, you can notice that there is no point in speaking this fast, because the receiver can only interpret, or it can only process the incoming data in this rate, right? So a sender needs to take care of this thing first. Okay, first thing is, it is receiver's responsibility. Okay, it is receiver's responsibility to tell sender that, boss, this is my communication speed, or this is my processing speed. Okay, I can take 60 words per minute, that is my maximum limit, not more than that. Okay, this is the receiver's job, this is the responsibility of the receiver. Okay, now after the moment this receiver has done this thing, now the responsibility shifts to sender, and it is the sender's responsibility. Okay, so now it is sender's responsibility to send data at 60 words per minute. As simple as that. Okay, as simple as that. So if you'll just conclude the meaning of these two lines, I think we can identify the objective of flow control. Okay, we can identify the objective of flow control, that is, it is nothing but a speed matching mechanism. As simple as that. Okay, so what happens in speed matching mechanism is, first receiver tells sender about its processing speed. The moment this thing is done, now it is the responsibility of sender to send data at that respective speed on which they have mutually agreed on. Okay, so sender is going to send data at this speed only. Alright, now if I'll conclude the whole discussion till now, we can say one thing, that your flow control is a mechanism that tells the sender how much data it can transfer before it must wait for an acknowledgement. Okay, this is what flow control is all about. Okay, now there is one more thing within flow control. A receiver has limited speed of processing the incoming data. Done. Next one, it has limited amount of memory. Okay, it has limited amount of memory in which it can store the incoming data. Since it has limited amount of memory, that is why the moment this memory is full, now the sender can stop sending the data and it must wait for acknowledgement. Okay, the moment an acknowledgement is received, the receiver can clear data from its memory and it can expect more data. As simple as that. Alright, so if I have a sender and if I have a receiver over here, and this is the channel, so let's say receiver can receive only 3 data. Okay, so let's say sender sends 1 first, so 1 has been stored here, then sender sends 2, 2 has been stored here, now sender sends 3, 3 has been stored here. Okay, obviously it is done at some communication speed, okay, on which sender and receiver both have agreed on mutually. Okay, now the case is, now sender must stop, okay, because it is flow control. So flow control is a mechanism that tells the sender when to stop so that it can wait for acknowledgement and then it can restart. Okay, now it needs to stop here because receiver is not having any further memory, right? So receiver is going to send acknowledgement back, then the data would be processed and sender can send the next data. Okay, so it would look like this now: 4, 5 and 6. Alright, now these are basics. Okay, these are basics. Now for flow control we have different set of protocols. Okay, now what are protocols and all, I am not going to jump into that, those definitions and all. You guys are grown up, so it is easier to know. Okay, now these protocols were divided on the basis of two parts. One is for noiseless channels and the other one is for noisy channels. Right, noiseless channels, we have different protocols. First one is simplest. Okay, next one is stop and wait. Then for we have these two protocols only for noisy channels. Now we have noiseless channels. Now we have noisy channels. We have stop and wait, ARQ. Next one is go back and ARQ. Last one is selective repeat, ARQ. Okay, we are going to discuss these protocols one by one from the coming lectures. Alright, so that's it for this short video and we'll continue later on. Thank you so much. Have a nice day.